but the actual lesson is about minimum and maximum values. Now, before we dive into an example, we know that if we have an equation, any equation in the form of fx, and we find its first derivative, that we can use the first derivative to find local minimum and local maximum points. And we substitute the first derivative equal to 0, and this will allow us to find a minimum and a maximum point. So on the graph, it was used to find the x values of the stationary points. Now we are going to move away from the graph and we are going to go into motion. Okay? And the example that I'm doing is on page 128 in the new textbook. So it says, I know it doesn't read really well, but okay, here we go. It says the displacement of a particle in meters from a point P after t seconds is given by st equals to 3t squared minus 60t plus 400. The particle moves in a straight line from east to west and back. The particle is initially west of P. Okay, so there is a particle and it's moving up and down like that. Now they ask us, how far is the particle from point P initially? Okay, so let's just make a little bit of sense of what we have. So the motion question, it's a bit of physics. So here we have a point P, and here we have a particle, and it's basically moving. And what they say is the displacement. So displacement means basically by how much it moved after a few seconds is given by this equation. Okay? And the first question is, how far is the particle initially from the point P? Now the word initially means at the start, if I can say it like that. And also what we need to know is that t represents seconds. So initially and at the start can also mean 0 seconds or a time of 0. Because when you start a stopwatch or start to make measurements, you start with 0. I hope that is clear. So the particle initially means I need to substitute t with 0. So it's 3 times 0 squared minus 60 times 0 plus 400. And this now is 400 meters, because they said the displacement is measured in meters. Okay, so here's important information. So displacement of a particle in meters from a point P after t seconds, so that's the amount of seconds, that's given by that equation. So now they ask us, how far are they apart from each other initially? That means at the time of 0. And I simply substitute it with 0. And they are 400 meters apart. Okay. Are there any questions? You guys are welcome to unmute yourself. Right. Okay. Just want to keep my phone on silent. If we get thrown off the call, just send me a WhatsApp. This time I'll get it. I hope. Okay. So the first thing you need to learn about motion is actually the word initially. And I hope you know that that's at the start or 0 time or seconds. Okay? Now, the next question is how fast in And in what direction is the particle moving after exactly 4 seconds? Now, we're going to speak about fast. Okay? So the word fast refers to a rate of change or speed. And right at the start of calculus, we said a rate of change is synonymous with the word gradient. So how fast the line changes or the equation changes is referred to by the gradient, is always measured by the gradient. So now that they ask how fast and in what direction is the particle moving after 4 seconds, they are speaking about find the gradient or the rate of change at 4 seconds. Okay? But that's the new information that you need to link now with the first derivative. So if I take the original equation and I take its first derivative, so that's the original equation, so it's 6t minus 60, all right? And what this would represent then is velocity. But we don't have to get into the technical stuff. As long as you know that speed or rate of change, or they speak about fast, they're referring to a gradient, okay? And next they say, and in what direction, and after how many seconds, okay? After 4 seconds. So let's start with the 4 seconds. So we simply substitute t with 4. Sorry, let's do that properly. Okay. And if I multiply out, that is negative 36 meters per second. We are using the units that they give us in the initial information. So remember, speed is measured by units per time, like kilometers per hour or so on. But in this case, they gave us meters and seconds. So our answer must be in meters and seconds. Okay? Now the direction in which we move. Now I need to just think properly. I don't want to confuse anyone. Okay. The point P and the particle, they said the particle, wonderful spelling, Mr. Vessels. They said the particle is west, all right, from point P. So what they are saying or suggesting, and this is where it gets a bit tougher, what they are suggesting is that the west movement would be positive. Then if I move in the other direction, it is negative. Right? And the other opposite of west is east. Wait, this is screwed up because I'm using that now, but west is on the other side if you use normal directions, but just use the sketch they give you, okay? So if I move in the opposite direction of west, that is east, and that will then be considered negative. So to answer the question on which direction are we moving, because it's negative, it's opposite the direction we are given, we're going to say that that is east, okay? Don't be too concerned if you get the direction wrong. That is not something that we are going to worry about. We can simply understand that it's moving at this rate in the opposite direction. So the way to help yourself a little bit, because it's negative, and you won't, if you are not sure about the direction, it would be 100% correct if you say we're moving 36 meters per second in the opposite direction because of the negative. So Does that make sense to anyone? So the negative, indicated there was some sort of turnaround point. Okay. But as long as you understand that fast means rate of change or speed, and we are going to use the gradient for that, because the gradient is the rate of change right at the start. Okay. Now we're going to continue. The next question I normally feel is unfair to ask because not everyone does science, all right? But the question is, calculate the acceleration of the particle. Okay? Are we all together? So calculate the acceleration of a particle. What we know is that the speed was 6t minus 60. That is now the rate of change or the speed. Okay, at a specific point. Now acceleration, if you guys that do science would know, acceleration is a fixed value. You accelerate at a specific rate, and that is fixed. You know, we don't really move that around. And what we do then is we find the second derivative to change from speed to acceleration. So that is 6. Okay? And also, if you do science, you know that the notation is a bit dodgy. Okay. So that means that every second, the next second, I'll increase my speed 6 times in the previous second. If that makes logical sense. And then the next second will be 6 times, faster than the previous second. And so it goes on the whole time. But in my personal opinion, asking a question around acceleration and speed is a bit unfair to pupils who do not have science. But as long as you know that speed or rate of change is the first derivative, then just safely assume that acceleration is the second derivative. I know that doesn't help everyone, but yeah. And I think the notation that you use in science or in physics is something like that. Am I correct? Are there still people online? I couldn't tell you. So, cool. So those who do not do physics, please don't get overwhelmed by this. They all workarounds, right? These are at least in maths is fixed. So second derivative is acceleration, first derivative is rate of change or speed, and the motion question is always fixed. They only use those concepts. They can't really introduce other concepts. It'll be unfair. Then they say, what is the minimum distance between the particle and point P? So what is the minimum distance between the particle and point P? Now what we do know is that for a minimum and a maximum, we take the first derivative and we set it equal to 0. And this represents either minimum or maximum. So sometimes they would ask, what's the maximum distance? Okay, and then obviously the equation would be set up like that. And what's the minimum distance? I'll explain now why this graph only has a minimum distance. Okay, but let's first find it. Okay, so I set the derivative equal to 0. And then I solve t. All right. So now, this t is not the minimum distance. This is 10 seconds. Okay? So this represents time. So at 10 seconds, we have our minimum distance. So minimum distance occurs at 10 seconds. Then we need to take the original equation, which was 3t squared minus 60t plus 400, and we substitute that with 10. Okay, so it's 3 times 10 squared minus 60 times t plus 400. That is equals to 100 meters. So the minimum distance between the particle and the point P is 100 meters. Okay. Now, before we continue, let me explain why this is a minimum. If you see this graph, not the graph, this equation, if I replace the equation with the normal notation which we use for graphs, it will be fx, and then it means I replace every t with an x. Okay. We know from grade 11 that this is a parabola. And from the value of a, it is a smiley graph. Okay? Can you guys see that? Now, if I were to draw this graph, it would look something like that. And the minimum distance is this point right here. Okay? So basically calculating the turning point. So that's the minimum value of the graph, because you can see it's turning and then it's going up afterwards. And what we have worked out now is that the minimum distance is at 10 seconds. And if I substitute the original, or the x value into the original equation, I get 100. All right. So you don't have to do this. It's just to show you that this represents, even though we're not using x's, this represents a parabola. And because it's a smiley face, it will have a minimum value. So if I had another equation, let's say st was equals to negative 4t squared plus 500. Okay? That negative 4 in front of the t squared tells me the shape of the graph. So it will be a frowny face. And now I can see this graph will have a maximum point. So that is sometimes why they ask you between minimum and maximum. Obviously, the maximum distance between these 2 points is infinite, because the distance can go on infinitely between them. But the minimum point is 100, is at that point there. But if the equation had a negative t squared, it will be a frowny face and it will have a maximum value. Okay, that is not something you need to be concerned about. It's just so you can understand that sometimes they'll ask for minimum and sometimes they'll ask for maximum. And you can safely assume they will keep to a quadratic equation. All right. They rarely go away from the quadratic equation. Okay. Then we have one more question. I'll post pictures on the group once I'm finished. The last question says, is the particle speeding up? Okay, sorry. Is the particle speeding up or slowing down after exactly 6 seconds and 12 seconds? Okay. So when they speak about speeding up and slowing down, you guys agree that they're speaking about, well, they're speaking about speed. So that would be the first derivative. So we know that the first derivative is equal to, sorry, just give me a sec, I wrote everywhere. So what I want to do is I want to find the speed at 6 seconds, right? So I'm going to put in 6 seconds here. So that is 6 minus 60, and that is equal to negative 24 meters per second. Okay? But if they say speeding up and speeding down, we need to compare that to the acceleration, which is a constant value of 6. Okay. I'm hoping you guys are following. Now, if I compare not the values, but the direction. So this is obviously accelerating, I'm going faster. This is a negative acceleration. So am I going faster or slower? A negative speed. Can you guys? Slower. So I'm going slower, or you can say slowing down. Okay? Then at 12 seconds, I do the exact same thing. So it's 6 times 12 minus 60, which is 12 meters per second. That's a positive value. And I compare that with the acceleration. Obviously, the acceleration is a fixed value. So now I can see it's positive and positive. So I'm comparing the direction in which I'm moving to 12. And this direction is both positive, so this means I'm speeding up.